Hello, everybody. Today we're going to talk about topic 6.6, properties of definite integrals. So remember, a definite integral is when I have an integral expression that is defined with an upper and lower limit. We're going to talk about some properties, and then we're going to try to apply those properties mainly analytically, a little bit numerically. But at the very top, I give you a graph, and I want the integral of the function from 0 to 12. So ultimately, I just want to accumulate the area under the curve from 0 to 12. So I'm going to just start adding up all of these areas. So I have a little semicircle here. The radius is 2. So I would do pi r squared divided by 2, right? Which would be 4 pi over 2, or in this case, 2 pi. Then I'm going to take this little triangle. I have 1/2 base times height. So my base is 2, my height is 2. So 1/2, 2 times 2 would just be 2. I have a little rectangle of 2. And then I have 1/2 base times height here, which would give me 1. All right. I'm going to keep going. I'm going to now switch colors because I'm going to go below the x-axis. So 1/2 base times height. This would give me a -1 because it's below the x-axis. And then I have a base of 3, height of 2. So that would give me a -3. So if I add this all up, if I go from 2 pi plus the trapezoid, which is a total area of 5, and then I'm going to say minus the little triangle that's below, which would be 4, I end up getting the area to be a 2 pi plus 1. Okay. Now, for number 2, if you go backwards, it would ultimately flip everything around. And that's one of the properties. If you end up flipping the limits, what we end up getting is we get the exact same answer, but opposite, right? So in this case, I would say I have a -2 pi minus 1. And I'm going to go into some more details with that here in just a second. So some properties of definite integrals. Okay, we're going to go through these one by one. The first one is if my lower limit and upper limit are the same value, then the area is 0. The width of that area is 0. If I'm going from A to A, it doesn't have a width. So therefore, the area inside that curve would be 0. Now, if you do a reversal of limits, so that's the one that we just talked about. So if my original went from B to A, and I switch it to go to A to B, then it just makes it an opposite sign. So I can write my limits going from smallest to biggest like they should be, but you just have to include a negative out front. If you have a constant multiplier, we can take that constant multiplier outside of our integral. So we can evaluate the area under the curve and then multiply it by the constant. That makes some of our integration a little bit easier. And then this is an interesting one. If you take the area from A to C and then the area from C to B. Now again, if you look at the top here, the description, C is between A and B. So I'm going to take the area from A to B plus the area from C to B. If I add those together, that ultimately just gives me the area from A to B of f of x dx. Okay, so if you add one shape, it's kind of like what I did here, right? I added the semicircle, and this is a separate integral. Ultimately, I can write that as just one big integral from A to B. That's kind of the idea. Okay. A couple more. You can always separate integration by addition. So I can do the integral from A to B of f of x dx plus the integral from A to B of g of x dx. Okay, so you can separate an integral with addition and you can separate an integral with subtraction. If you notice, though, there is no multiplication here. You cannot separate an integral with that is like f times g. You can't do that. There's special rules for that we'll learn, and we'll go through those little by little. All right. So if we go back to this graph that we had earlier, right? This is the same graph that we started with, and I want the integral from 7 to 6. Well, those limits are backwards. Okay. So I'm going to put a negative out front. So I want to know what is the integral of this function from 6 to 7, and then I'm going to multiply it by a negative value. So if I go from 6 to 7, I'm referring to this rectangle, which has an area of 2, but remember that negative out front, I get a negative 2 for my answer. Now, furthermore, I'm going to do this next one in 2 steps. I'm going to say, okay, this is going to go from 8 to 12 with a negative out front of 3f of x dx. But then I can take the constant multiplier of 3 out, and I would go from 8 to 12 of f of x dx, right? So let's find out what the area from 8 to 12 is. And that's going to be this negative area down here. So 1/2 base times height, so 1, 2, 3, 4, and my height is 2, so it'd be 1/2 4 times 2, which would just be 4. So I'm going to get a negative 3 times a negative 4. Now again, the 4 was negative because it was below the x-axis. It was a negative area, so I end up getting a positive 12. That would be my answer. Okay, so let's take a look at just some little practice here. Given the following information, so I want you to kind of see, we have this integral, and we have this integral, right, from 1 to 5, and then from negative 2 to 1, right, of g of x. So if I want the integral from 5 to 1, well, that's the same thing as saying a negative from 1 to 5 of f of x dx. And we know from 1 to 5, that's going to be a negative times a negative 3, which would be a positive 3 as my answer. Okay. Now, if I want to go from negative 2 to 5, watch what I do here. I'm going to say from negative 2 to 1 of f of x dx plus the integral from 1 to 5 of f of x dx. And now I can just add those integrals together, which gives me a value of 1. Now, I can further deconstruct this one, part C, to be the integral from negative 2 to 1 of f of x dx plus 2 times the integral from negative 2 to 1 of g of x dx, right? So this would be 4 plus 2 times 8, which would be 4 plus 16, or in this case, 20. Part D, the integral from 0 to 1. Okay, now we don't really know anything about this function from 0 to 1, right? So not enough info here. Okay, not enough information. What about from 1 to negative 2? Okay, well, if I go from 1 to negative 2, that's just the flip-flopped of the other version. So I'm going to say negative times the integral of negative 2 to 1 of 3 f of x dx, which would be a negative 3 times the integral from negative 2 to 1 of f of x dx, which would give me a negative 3 times 4, or in this case, a negative 12 as an answer. Okay. And then last but not least, what if I went from 5 to 5? Well, if I went from 5 to 5, if the upper and lower limits are the same, then regardless of what's in the integrand, that's going to be 0. Okay. All right. Well, piecewise functions, right? So what I'm going to do is I'm going to graph this piecewise function, then I'm going to find the area under the curve. So what is the value of the integral from 1 to 5 of dx? So when it's less than 2, so we're going to put 2 on here, my function is a constant 3, right? Open circle, constant 3. When it's greater than 2, I have a 4 minus x, so I'm going to go from 2, and it has a slope of -1. Looks like this. So what would the integral be from 1 to 5? Well, the open circle doesn't make a difference too much. I'm going to find the area under the curve on the left from 1 to 2, right? And then I'm going to find the area under the curve from 2 to 5, right? And that would be the idea here. So if I do this, the area of the blue section would be 3, right? Let's do that in blue. The area, now green, I have a positive and a negative here. So the part that's above the x-axis would have a height of 2 and a width of 2. So it'd be 1/2 base times height, which would just be 2. But then when I go below the x-axis, I'm going to be at a -1/2 as my area. So if I add that all up, I get 4.5 as the area between that curve and the x-axis. Now, if I graph x minus 2, well, that would be an absolute value graph 2 units to the right. Slope is 1 because the coefficient in front of x is 1. And I want to go from 0 to 5. So I want to go from here all the way to here. Well, I just have 2 triangles that I need to add together. So 1/2 base times height would give me 2. 1/2 base times height would give me 9/2 or 4.5. So I get something like 6.5 for my answer. All right, I'm going to keep going. So what's the difference between these two functions? Well, if you have the absolute value around the whole integral, all I'm going to do is I'm going to remove the direction. I'm just going to take the magnitude of that answer. Okay, so if I were to take a look at this, this part over here, the radius is 1, so it'd be pi r squared over 2. So that would just be pi over 2, but it's negative, right? This is a positive pi over 2. And then over here, I have this triangle that is 1/2 base times height, so it's going to be 2. Now, if I were to do this, I would take the absolute value of a negative pi over 2 plus pi over 2 plus 2. You would have to add all those terms together first, and then take the absolute value. That just gives you the answer of 2. But if it's written the other way, if I take the absolute value of each of these, I'm going to take the absolute value of each of these areas first, then add them together. Right? Do you see how I set up each of those absolute values separately? So now I can say pi over 2 plus pi over 2 plus 2, which just gives me a pi plus 2 as an answer. So those two expressions, although very similar in same operations, the order in which they're written is different, which is going to give you two very different answers. So if the absolute value is on the outside, just take the absolute value of your answer, the magnitude of your answer. If the absolute value is within the integral, then just treat every area as though it were positive and add them all together. Okay? All right, using a calculator, find the integral value, right? So if you were to graph this function, we would then want to find the area under the curve. So if you were to graph this function, we get something like this, okay? And I want the integral from 2 to 3. So from 2 to 3, so I want this integral. Now we can use our calculators to evaluate. You can do from 2 to 3 the square root of x minus 1 dx. And you do that by hitting the math button. And then I believe it's number 9. Okay, and that will set up a nice little integral on your calculator. I'm going to do it on the calculator beside me here. So from 2 to 3 of the square root of x minus 1 dx, and that gives me an area of 1.218. I'm just going to terminate. I'm not going to round up or down. Okay, I'm just going to terminate that decimal. Now I can do the same thing. Okay, if I start at the y-intercept of -1, sorry, I go up 1/3, right? I get a graph that looks like this. And I want the area under the curve from -2, right, all the way to 4. So odds are this is going to be negative, right? I have more negative in my calculator, so I'm going to use that math number 9 from -2 to 4 of x/3 minus 1 and dx, and that gives me a value of -4. Okay, now we will, in a future topic, we will learn how to do these integrals by hand without a calculator, but for right now, I want you to get comfortable with that calculator feature. Okay, now there are a bunch of practice problems here. I'm going to have you do those. I will post the answers to these practice problems so that way you can see them. Okay, so hopefully this helped, and I'll see you soon.